L systems generate sentences and translate sentences into geometric structures. So they start with an axiom, which is just the initial string, and then a set of production rules, which generate longer strings from that initial string, and then translate into geostructures. For example, if an initial string was this thing, and then the rules were change f into this string or axiom would be changed into this. After another iteration, it would be changed into this. Then that string would be translated into a structure like this by reading each character and doing the instructions. So F and G would be draw forward, plus or minus means turn left and right by a specified angle. And there are also certain L systems with brackets that push and pop the current values of the angle and the position onto a stack. So to implement sentence generation, we can define a class L system that takes in a string, just as the initial string or the axiom, and a set of production rules. And we can have a function or have it return a string. And we can make this sentence. So the sentence is initially just the axiom, the initial string. So if we define a main function, we can make a new L system. The axiom can just be this example, F, and the rules, I'll make a dictionary, change F Why is this not working? So change F into this, so a dictionary that maps the input into the output, and then let's just print out the system. So see, it prints F, and it just returns, or just prints the axiom since we haven't applied the production rules. So we can apply it with a function called generate that makes a new string by looping through all the characters in the sentence and maps it to either just itself if it's not in the rules, if its key is not in the rules dictionary, or maps it to what it's supposed to be mapped to. So if there's an exception, we don't do anything. Then we concatenate the mapped thing, and then we set this sentence to the new string. So let's generate. Let's test if this works. Let's print again. And generate again, and then print again. So hopefully this works. Sentence is not defined. Oh, characters and self.sentence. Okay, looks like it's working. First generation is just f, then this thing, and then third generation. It looks like, yeah, looks like it's working. So we've done the sentence generation. Now we have to implement drawing. So we can get rid of all of this. Let's set up Pygame. So we can import Pygame and initialize, get the size of the screen. We can make it 500 by 500. Grab the screen from Pygame, pass in the size, set up the main loop while it's running. You're going to get the events if the event is the quit event, which is when the user presses the X button, make running equals false. Otherwise, we're just gonna flip, which is just updating the screen. Then once it's breaking out of the loop, we'll quit. So let's test if that works. Alright, so we have a 500 by 500 window. It closes. Now let's get command line input. So we'll have to import this and get some variables from sys. So the size of the screen, actually we'll get command line input and we'll get a certain file as a command line argument, and then we'll use that file to translate what I have here. So I've just copied examples from Wikipedia and paulbork.net of different Fractal or different L systems, and I've copied their axioms and how many rules they have, and then the rules separated by space, and then finally the angle. So let's get the system L system sys text. We can make that the first argument, and then size of the screen can just be second and third arguments, and second and third. What other arguments do we need? We need some important values we need are the length, the start position of our L system on our screen. That's going to be the same thing. Can make that arguments 4, and arguments 5. And then we can get the length of our initial. So whenever we draw an L system, when it draws forward has to draw forward by a specified length. So let's get that as input. Length equals sixth argument. And then another thing we need is a ratio. So the ratio is just every time we generate a new sentence, so as the sentence gets bigger, we need to decrease the size of the length by a certain factor. This is just so that it can fit on our computer screen and we don't have to zoom out or anything. So after that, we can use all of these command line arguments to construct our L system. And our L system needs to take in the start, so where the L system starts drawing from on our screen, the length, and the ratio. Some other important things are d theta, so the angle by which we turn whenever we get a plus or a minus sign in our sentence, which is specified in the text files. And I think that's it. So we can set theta initially to be pi over 2, and it's important math. So initially we're going to draw a string, or draw a line, if we get f, and we haven't turned anything, or we haven't turned by d theta, we're going to draw a straight line going up. D theta will just be d theta. Start, the x and y will just also initialize this start. So this is our position when we're drawing, which will get moved around as we draw. And the length, just be length, and the ratio as the ratio. Okay, so once we have the text file as an argument, we have to open the text file. So let's open L system text as file, or F. And then first line will just be the axiom. So axiom equals f.readLine. And should probably set the system to be at first none. But then we're going to set the system to our constructed system, or L system, once we have all the arguments read from the file. Axiom is the first line. The number of rules, the sum of the rules. Some of the L systems have 2 rules, like this one, and this one, but this one just has 1. So let's just get how many rules is just the next line in the file. And then for how many rules there are, we're going to make a dictionary and append whatever rule from the text file. So let's read the line, get the rule, and we'll split by spaces. I think it's already like that by default. So the first index, or the 0th index in rule, so rule is an array, will be the input, and then the output will be the first, or index 1. So rules at rule at index 0 will just be rule at index 1. and that will do for however many times I is. I think that's it. Let's construct the L system, the axiom, the rules dictionary, d theta. Oh shoot, we need the angle. So d theta. Wait, this has to be. Okay, d theta equals. We gotta convert to radians. The next line, which is we gotta cast int the next line. So we got d theta. Now we got start, which is we already have length and the ratio. So yeah, that looks like it works. So yeah, looks like we've got all the important variables read in from command line arguments and saved into the L system in the constructor. Now we have to implement the draw function in the L system class. So let's define draw function. Draws to a screen given to it from Pygame. So let's make it draw every time we click on the screen. Dot mouse button. Wait, is that right? Mouse button down. Down. We're going to do system dot. I'm going to draw whatever we have onto the screen that we've gotten here, and then we're going to generate the next generation of the sentence. Actually, before that, we should fill with white to reset whatever we had before. Let's fill with black. Let's draw with white. So we're going to loop through the sentence that we have. So if the character equals f or g, so I have that because in all L systems, if there's an f or g, we draw forward by our current length. So in Pygame, to do that, you need an initial tuple that represents the Cartesian coordinates of the initial position of the line, and then the final position of the line. So it'll just be draw a line onto the screen at a specified color. Let's do white. From the initial position, which is just xy, and final position, which we'll have to set as our current position minus the length times the cosine of our current angle. Same with y, except we'll use sine. So this just gets the component of the length vector in the respective directions, and we subtract that from the current position because the graphics coordinates are inverted. So we draw from xy to x2, y2. Then we want to set x and y to x2 and y2. So we basically moved to our final position. Else if it's a plus, we'll do what this says. Plus or minus means turn left or right by an angle. So we can implement that just by adding d theta, which was read in by the file, or the other way. Lastly, the most confusing part is probably the brackets. So if we get a open bracket, save the current value of position and value, or position and angle. So push it onto a stack basically. And then if you get an open bracket, pop off the stack, or pop off the position and angle from the stack. So let's implement this with Python list. So if we get an open bracket, let's pop onto the stack, just appending the current x position, x current y position, and the current angle. Self dot should probably be called positions. Yeah. And other way around, we'll pop. Oh, this is push. This is pop. Okay. Pop off the stack. Set x, y, and the angle theta to be position at x, position at y, and position. So this gets whatever was previously popped, or whatever was most recently pushed onto the stack. And if it's not any of these things, we don't draw. It doesn't influence the draw function. So some of these have like x, and x doesn't influence the drawing directly. It just influences the sentence evolution with its rules. And then yeah? What? Right here? Upstairs? Yeah. No, it's fine. Okay. So now we've implemented the draw function. All we need to do is to run it, and hopefully it works. So let's run Python our file. First argument is the text file. Let's try tree.txt. Let's initialize the size of the screen to be 500, 500. Start in the middle of the x-axis, but at the very bottom of the y-axis, since it's a tree. Length of the initial L system, 150. Ratio, we make that half. Okay, oh, this has to be a float. No attribute read line. What did I do? 68. With open as oh, this has to be lowercase. Read line. Read line. There you go. I missed one. Where is it? line 72. Oh, there it is. Whoops, what happened? No attribute position. Self, I probably positions. Oh, okay, so whenever we generate, we have to restart X and Y as our starting position, so it doesn't fly away. Also, we probably need to set theta back to pi over 2. Oh yeah, and also make the length by its ratio. And let's run it. Start. Oh, self. There we go. We have a beautiful L system, and it makes a cool looking tree. Another interesting thing we can do is to make it pretty. So we can vary the RGB values as character iterates through the sentence. So let's get set color equals to 0 and decolor equals 255 divided by the length of the sentence. So, and then we'll increment decolor after each iteration is equal increment color by decolor. So after we've gone through the length of the sentence, color will be equal to 255. Then we can set red to be 255 minus color. So it'll start out as 255, but then it'll decrease in its red value. We can do the opposite for this blue value and do a compromise 155 plus decolor divided by 2. So this will also be approaching 255. Let's run that and see if it works. There we go. We got some nice colors going on. We can also test this out with these other 4 text files that I have. Let's try with plant.txt. It makes a cool plant. So yeah, it's a cool looking plant thing. You can also play around with the size of the screen, because we have it as command line arguments. Let's make the width to be 1200, the height to be 800. Start at the bottom, so X, bottom in the middle. Let's make this 600. So start in the center with respect to the x-axis, and the bottom of the y-axis. Make the length of it higher. So maybe instead of 150, 250. There, get a cool looking tree. Just pretty neat. We can get that just from string generation and this weird kind of drawing logic. Let's test it out with triangle.txt. I think we should put it in the middle, 400. So kind of a cool triangle fractal pattern happening. Let's make its initial length. Let's make the ratio slightly higher. Make its initial length also higher. So yeah, interesting fractal pattern happening. You can kind of see how the fractal pattern is being drawn with the colors. Let's try Sierpinski. Sierpinski.text. I think this one works better if start at the very bottom right. Let's make this 1200, 800, and the ratio, let's make it 1/2. Okay, we can make the length a bit larger. Let's do 700. So yeah, it's an interesting fractal pattern occurring. Lastly, we can do dragon.text, which is the dragon curve. And all of these are just generated with these different text files, where there's just the axiom, the rules, and the angle. But dragon, let's do that. Let's change this to dragon.text. Start in the very middle, 600, 400. Let's make the length 200, the ratio 0.75. Yeah, we can make a cool dragon curve just with strings and a little logic. There you go. Those are L systems.